In this question, we have two boxes, which I've labeled box A and box B. They are connected to a pulley and will move in the direction that I've shown you with these arrows. We are told that the coefficient of kinetic friction is 0.5, and we want to know what is the acceleration of each box. Now the first thing you want to do is draw a free body diagram, and we will need two, one for box A and the other for box B. Starting with box A, we know that there will be a tension force from the rope, there will be kinetic friction, and there will be the force of gravity and the normal force. Then for box B, we will have the force of gravity, and again we will have the tension from the rope. Now according to Newton's third law, the tension force for object A could be called the force of B on A, because object B is pulling on object A. And the tension force on object B could be called the force of A on B, because object A is also pulling back on object B. And now the reason I mentioned Newton's third law is because it tells us that these tension forces have the same magnitude. And that makes sense, because box A and box B are connected by the same rope. Now that we understand the forces acting on both these boxes, let's write the Fnet equations. Let's start with box A. Here we have our Fnet x equation, which will be the sum of all the forces acting along the x-axis. So that would be the tension force minus the kinetic friction. We can replace Fnet x with ma, and we can replace the kinetic friction with mu kn. Now looking at the kinetic friction, we were given the coefficient of kinetic friction, but we don't know the normal force. How do we find the normal force? Well, we need to write an Fnet y equation, which would be the sum of all the forces acting along the y-axis. So that would be the normal force minus the force of gravity. We can replace Fnet y with 0 because box A is not moving up or down. And we can replace the force of gravity with mg. Now if we rearrange this equation, we see that the normal force is equal to mg. And with that, we can plug the new value for the normal force into the equation. Now let's move on to box B. Here our Fnet equation would be the tension force minus the force of gravity. We can replace Fnet with ma, and we can replace the force of gravity with mg. Now the next thing I'm going to do is rearrange and isolate for the tension force. And the reason I do that is because I can take the value of the tension force and plug it in to my object A Fnet equation. And the reason I can do that is because the tension forces are the same. And so when we make that substitution, we're left with this equation. And looking at this equation, the only variables we don't know are the accelerations A for box A and A for box B. But remember, these two boxes are connected by a rope and they're moving together. So their accelerations are going to have the same magnitude, but different directions. And that's why we say the acceleration for box A is equal to the acceleration of box B. The acceleration for box A is positive and the acceleration for box B is negative. So what we're going to do is replace the acceleration for box A with negative the acceleration for box B. And so I'll plug that value into the equation. And then from there, all I need to do is rearrange the equations and isolate for the acceleration AB. And once I've isolated for AB, I can plug in my values. And with that, we find that the acceleration for box B is equal to negative 4.9 meters per second squared. And now that's the acceleration for box B, but how do we find the acceleration for box A? Well, we know that the acceleration for box A is equal to negative the acceleration of box B. So all we have to do is plug negative 4.9 meters per second into our equation, and we find that the acceleration for box A is positive 4.9 meters per second squared. So you can see that both boxes have an acceleration with the same magnitude, but opposite directions. And that's how you answer a forces question when the objects are connected to a pulley.